Okay, so this is section 1.7. It's parent functions and their transformations. The quiz that you're taking this Friday is over sections 1.5 to 1.8. So we're going to do notes tomorrow on different operations with functions, and that'll also be included on the quiz. Most of what we're talking about here is a review from Algebra 2 or Algebra 3. Probably the newest thing is that we've added a parent function, the greatest integer function, that you can now shift just like you've shifted all of your other functions. So, first thing we want to look at is an example, and this is modeled after like what your homework is going to be like. So it's going to ask you 4 different things, and to be well prepared for your quiz on Friday, you should feel comfortable answering A through D. So we are given a function g of x, and we want to do these 4 things. Identify its parent function. That should be an easy one. Describe the transformations. You're probably pretty good at this. Sketch a graph. That's not too bad. You want to draw your graph nice. It doesn't have to be the most excellent graph you've ever drawn, but it should be located in the right spot with maybe a couple extra points to make a nice graph. And then D is probably a little bit newer, writing the function notation. So in function notation, it's just going to be that f of x, and we're going to see the different numbers in the transformations, but there's not really an equation there. Okay. So we've got g of x equals negative 2 times the square root of x minus 3. What's the parent function for this graph? F of x equals the square root of x. If you don't know what your parent functions are, look at your A basic function sheet. Should be one of those. So it's like square root of x squared, absolute value of x, greatest integer of x, whatever that may be. Part B, describe the transformations. Look to your group members real quick for me and tell your group members what the transformations are for this graph. Yeah.
Oh, yeah, that's right. That's our reflection 2 and the reflection.
I don't know. Yeah. I think it goes right 3 vertical stretch and then it goes towards right 3 plus.
Okay, as I'm walking around, these are the 3 transformations that I hear. Okay. Moves right 3, reflecting the x-axis, vertical stretch of 2. It does not matter what order you list those transformations. You're just listing the 3 transformations. So you see added to the square root of 2, there is a negative, the square root of x, there is a negative, there is a 2, there is a negative 3. So what are those things doing to our graph? And then part C, you're going to use those things to then sketch a graph of your function. Now, you have to have some knowledge about your parent graph in order to be able to do this. So I know for the square root function, it starts at 0, 0. And then the square root of 1 is 1. And I can even extend that. The square root of 4 is 2. And that's my graph. Okay, so you got to know the shape. You probably want to know like 1 or 2 of the closest points, just so if there is a stretch, you can get an accurate picture. Okay? But those aren't hard to find in a parent graph. And then you want to perform these transformations. So I know that I'm going to take this graph and I'm going to translate it right 3. So that's just sliding it to the right. And I also want to reflect it in the x-axis. So reflection in the x-axis is then going to make my square root be going down. Okay. And finally, there's a vertical stretch of 2. When you vertically stretch your 2, it means like you're really stretching your y values. So where you would normally just go up 1 to get to your next point, now you're stretching it by 2, so you got to go up 2 to get to your next point, but that's being reflected, so it's going to be a down 2. Okay, so we have a start point, 3 to the right. The next point, normally we would go over 1 and then we would go up 1, but we stretched it by 2, so that would be up 2, but that's also being reflected, so we're going to go down 2. And then if I wanted to do another one, I would have to be able to go 4 out, and then instead of going down 2, I would go down 4, because it's gonna double. But I'm running out of room. Yes.
Last year they said just like, oh, if it's a vertical stretch, draw it like a little bit like taller. Do you want
I want you to do like an extra point, right? If I got that extra point, I can see clearly, that stretch of 2 is gonna increase it by 2. So yeah, you can do the actual point. I have faith. They're not hard to find. Like if you're having trouble, just do a paragraph and figure out what that first jump is, and multiply your y value by your stretch. Okay. And then part D, this is probably the newest part, right? The function notation. So what I want to see in D are these transformations from part B in the function notation. Okay, so the f of x. But if I was doing function notation with f of x, a reflect in the x-axis would be a negative in front. A vertical stretch of 2 would be multiplying by 2 in the front. So I'm going to have negative 2 times f of, and then to move right 3 would be x minus 3 in parentheses. So x minus 3. That's function notation. Please note that in function notation, there is no square root. For all I know, that could be a square root, absolute value, quadratic, cubic, greatest integer. I only know to draw the square root graph because I know the parent function is the square root of x. Okay, but function notation is just f of x with the numbers in the transformations. Does that make sense? Okay. So I want to do one other quick example here, and it's one that's a greatest integer function because that's new to us, so maybe seeing another one would be a good idea, and we'll look at the ones on our homework after we get done with our notes. And I want to do one with a multiply inside with x because that's what kind of transformation? A horizontal stretch or shrink. So we want to talk about this one real quick. Same set of instructions, g of x equals the greatest integer of 2x. Okay, f of x, the parent function, is the greatest integer of x. Easy. Transformations, since the multiplication is happening inside, it's horizontal. If it's 2, is that a stretch or a shrink?
Shrink.
That's a shrink. When the value of c is greater than 1. It's the opposite of what you think it will do. Normally a vertical stretch would make it, or vertically that would stretch it. Horizontally it's going to shrink it. So it's a horizontal shrink. Does anybody know what factor? By a factor of 1/2, the reciprocal. Okay, so you guys know about h from Algebra 2. You always said h looks like the opposite. Okay, when you're doing the horizontal stretch or shrink, instead of looking like the opposite, it looks like the reciprocal. So when it's a shrink, it's going to be a fraction factor. When it's a stretch, it would look like 1/4 in the equation, but then it's by a factor of 4. It's reciprocal. Okay. So it's a horizontal shrink by 1/2. We're going to draw a picture. So we got to be thinking about our greatest integer function. And we know the greatest integer function, okay, starts at 0, 0 with a closed circle, has a step of length 1, but it has an open circle at 1 because at that point the greatest integer would be 1, so it jumps up. And then it has a length of 1, open circle, jumps up. Has a length of 1, open circle, and that repeats down here too. Okay. So think about if you're going to horizontally shrink this graph by a factor of 1/2, what happens to your steps? They become smaller, shorter, right? And if we're shrinking them by a factor of 1/2, they're going to be 1/2 of what they once were, which was basically 1 unit. So now they're going to only go to 1/2. Because you're only shrinking it horizontally, the space in between the steps is going to remain the same, which is 1. Okay? So I'm going to draw a coordinate plane and place some steps here for myself. So when I horizontally shrink it, it's not going to change its starting point. It's still going to be a 0, 0. But instead of going all the way to 1, I'm only going to go to 1/2. It's going to be shorter. There's an open circle. Right above that at 1/2, that's when I jump up 1. Okay, so there's going to be a closed circle at 1/2 1, and then I go half the distance. And then I jump, and I do half the distance. Down below, I could have an open circle, and it's only going to go to -1/2. If you want to test that to make sure it's right, like this point is 0.51. If you put 0.5 in for x, times 2 is 1. The greatest integer of 1 is 1, so it should be up 1. And you can keep doing that if you want. So the steps are skinny, short. We're okay with that? Okay. And then part D on that one, function notation would just be f of 2x. That one's easy. There's only one transformation to put in there. Okay, last thing, I'm going to let you work this one out with your group members, and we'll put our answer up here in just a moment and see if we agree. Can you do 3 things for me? Identify the parent function, talk about its transformations, write the equation. Talk to your group members, see if you agree with this.
Looks like it went. And it also looks like it did. Oh, and also up to like.
That's one.
We don't know how many. We just oh, actually just.
That was like.
I mean, unless they're kind of trick us on.
Yeah. It's one.
I know it's up to.
No, it's not one.
No, as well.
What do you mean?
Also, 2 as in T-O-O.
Oh.
También.
It can't be open.
Yeah. It's a horizontal, so it'd be nice back, right? Yeah. I respect right.
Paragraph is f of x equals x squared because we see a parabola, so it's a quadratic. We can recognize it by a shape. Just shout out, what are my transformations?
Flexion.
I heard left 1 and reflecting the x-axis, and up 1. Okay. And then apply those to write a new function. So I'm going to call it g of x just because f of x is my parent function. I wouldn't take off if you wrote f of x right there, but g of x equals, reflecting the x-axis is a negative in the front. I gotta have a group of parentheses for my left 1. That should be x plus 1. It's the opposite of what I think it will be. Square it so that it looks quadratic, and then up 1 we said, so plus 1 in the back. We have an equation. If you wanted to test for a vertical stretch or shrink, think about your parent graph for the quadratic starts at 0, 0, and then the first point on that side of the parabola is like up 1, right 1. So you would just check from your vertex to like the next point, 1 over, what was your vertical distance? Well, it was down 1 because we reflected, but it's still only a distance of 1, so there was no stretch or shrink. Had I had to go down 2 to get to a point 1 over, then I would have had a vertical stretch of 2. All right, your homework assignment for tonight is on your gold sheets. These problems. Over here for 47 through 53 odd, this means I would expect you to have 47, 49, 51, and 53. You can choose to do the evens in the middle there if you want some extra practice. But I'm expecting you to do all of those odd problems. And then Friday, we're going to do function yoga before our quiz, so dress appropriately. I'm talking to the guys here. Please don't wear your shortest shirt so that every time you reach your arms up, we'll have to look at your midriff. Wear appropriate clothes so you'll be concealed. Yeah, that's for the guys. And don't wear your shorter shorts, so if you'll bend over, we see more than we want to see. The only cheeks we want to see in this room are on your face. Okay. And then quiz on Friday, so make sure you're prepared. A lot of you are looking like, oh my goodness, what is happening?